So I think if you keep your wits about you, working with complementary and supplementary isn't brutally challenging. And it doesn't take too many examples for these to become nestled nicely in your comfort zone. So here's our last little example of these. It's nothing special. It's very straightforward. So we're given angle P and angle Q are complementary. And we're also given that measure of angle P is 4x plus 5 degrees. And angle Q is 3x plus 15 degrees. And we're asked to find the measure of the two angles. Complementary means, of course, the angles add up to, you tell me, yes, 90. And so this should be pretty straightforward to work out. I've had students ask me in the past, and I wanted to use this example as a chance for this. Students want to know, how do you know, first off, is it clear why I'm using a right angle? Yeah, complementary means they add to make a right angle, right? The sum is 90 degrees. And so if I have students in the past, they'll ask me, how do you know where to put this angle that separates the two? Where to put this ray that separates these two angles? And the point is, you don't know. And so just slap, it doesn't matter. If I call this angle P, and I call this angle Q, I'm not concluding that angle P is the larger of the two angles. It could be, I don't know. That's the whole point. If I knew them, I wouldn't be asked to find them in the first place. And so when you draw your picture, or when a picture is given, unless something is explicitly stated in the picture, in the given information, you may not argue, you may not reason, you may not assume from the picture. And so from this picture, everything that's given here, you may not assume that angle P is the larger of the two, but one of them is. And so just when I draw this picture, it could be, I don't know what's going to happen yet. It could be that this might work out to be 20 and this might work out to be 70. And I've done this, I've had students do that before. They drew this picture, this worked out to be 70, this worked out to be 20, and they ask, what did I do wrong? The answer to that question is nothing. You don't get to assume based solely upon the picture. So one of them is larger than the other, maybe. I don't know which one. We don't know what's going to happen coming out. We just need to go ahead and trust ourselves that the process is going to work. What we do know is this. We know if you add these two numbers together, 4x plus 5, and the other is 3x plus 15, we know that total is 90. And so what do we have out of that? We have, we have 7x, what is that, plus 20 is equal to 90. And that implies 7x is equal to 70. That gives us x is equal to 10. Remember, we're not finished until we find our results, right? So we know angle P, where's my number here? That's 4 times 10 plus the 5 is 45. And we know angle Q is whatever this says. 3 times 10 plus 15 is equal to 45. Again, if you do not have the degree symbol, this is not going to get full credit out of me. So anytime you have this final result, if it is in degrees, you must put the degree symbol, right? Now, and in fact, this is what happened in this case. In this particular circumstance, they worked out to be the same size. Sometimes students will see this, they'll look at this picture and they say, well, what went wrong? Nothing is wrong. We didn't know they were going to be the same size, so we just made a picture that illustrated the given information as best we knew, and it turns out that this was not a sufficient picture. Once you know the information, if there's some reason to do so, then you could draw a more accurate picture, and now from here on out you would use this one instead of that one. But if all you're asked to do is find the measures of the angles, let sleeping answers lie, and just back away slowly and kind of don't make eye contact. So there we go. Angles are complementary. They sum to 90, and a little bit of algebra takes care of the rest of it.